Yes, good morning, Karen.
Good morning, sir.
Did you go through the work I sent you? The other work I sent on the group where you're supposed to open and then read through differentiation. Yes, Joel, did you go through the work? Welcome. So today we are looking at differentiation, and we shall basically focus on the introduction part of differentiation. And I expect that you have done some little reading on the work that I sent you on the site. So who can read for us this first sentence? By show of hand. Yes, Joel.
Hold infinity in the palm of your hand. The picture illustrates one of the more frightening rides at an amusement park. To ensure that the ride is absolutely safe, its designers need to know the gradient of the curve at any point. What do we mean by the gradient of the curve? It was in this video.
Okay, so do all of us know how to find the gradient of a line? If you are given any line segment, those who are able to put up your hands, those who are able to, who can be able to find the gradient of a line. Okay, Karen can, Joel can. Emile, do you know how to find the gradient of a line?
Yes, teacher, I know how to find the gradient of the line.
Okay, that is good. So our this video, I expect that you have watched it because I sent that work earlier enough for you to go through that. So we are going to go to our first image here, which shows a curve y equaling fx, and then a line, and those two have a point where they meet. So how do we find the gradient of a line? How do you find the gradient of a line?
change in y out of change in x.
Okay, so we get change in y over change in x. So by doing that, we'd be able to get the gradient of this line segment. Okay, then going to the second one. So what are we able to notice in the second image, or in our second illustration? What are we able to see about this image here? What are the differences between it and the previous one? Yes, Joel?
They have a tangent. Okay, they have a line crossing in between them, which is the woman called it delta x and delta y. In the distance, we have delta y on the y-axis and then the delta x. So they have a point in common where they meet, and that point, the line of segment.
So they have a common point where they meet. Okay. Any other? Kellen, what are you able to see? Emily, what are you able to see in this image here?
All the lines have the same meeting point.
All the lines have the same meeting point. That is good. Any other? So on this second illustration,
Curve.
Okay, Joel. So we are able to see that it is a curve.
But the
Okay.
yes, I think it.
So we have these points passing through a common point, as most of us have identified, and that is a point P, which is 2, 4. And all these lines are tangent to the curve y is equal to fx at that very point. So they are touching the curve at that point. Then we have one of the lines which is cutting the curve at 2 points, which is P and Q. And then when we are given these 2 points, we could easily find the what? The gradient of this line that is cutting the curve at the 2 points. So who can explain to us how that gradient is obtained? Because we have earlier said that the gradient is change in y over change in x. So we are now given point Q, which is 39, and point P, which is 2, 4. So who can give us an explanation of how we get the gradient? Joel?
Teacher, to find the gradient, we shall
Yes.
have from the formula change in y over change in x, whereby change in y is y2 minus y1 over x2 minus x1, and whereby our y2 is 9, and then our y1 is 4 over then 3 minus 2, our x2 is 3, and then our x1 is 2, and we shall obtain a 5 out of 1, which is 5. That is our gradient.
Okay. So we are able to get our final answer of gradient of that line as 5 by getting 9 minus 4 over 3 minus 2, which gives us a 5. So that is taking us to our second image, our other image here, when we are requested to find the gradient function of y equaling to x squared. So there we are picking any 2 points, maybe for ease of work. Let me explain this on a whiteboard. So we are given, illustrate it here quickly. So this is y equaling to f of x. So then we have okay, so this is y equaling to x squared, because we want to find the gradient function of y, of the function y equaling to x squared. So we are going to begin by letting x to be equal to a. So we have seen that we have a point A somewhere. So we had points P, and then we had another point Q here. And our interest is to first find the gradient of this line. Then later we use that knowledge to find the gradient of the curve at that point. So if our x is a, what would be our y value? If x is a, what would be the y value?
A squared.
A squared. So that means here would have a and a squared. Okay, so we are assuming that here we have a smaller change in y in x, which we call h. So which goes up to that. So that is a small increment in what? In h. So what would be our new point of a? What would be the x coordinate of q? if the x changes by a small value, which we are calling h, okay, let me make it a bit simpler. So if here is 0, then here we have a, and from this point up to this point, we have added h. What will be the point at this? Maybe if we could call this one n, what would be the value of, what would be the point at n?
A plus H.
A plus h. Thank you. Now that means the x coordinate for q is going to be a plus h. So if that is the x coordinate, what would be the y coordinate? Using y equaling x squared.
S squared.
Yes, come again.
Y is S squared.
Y is s squared. So remember here, our x is a plus h. And then our y is supposed to be x what? X squared. So what would be the the y coordinate?
A plus H into bracket squared.
A plus h into bracket squared. So we just get this, which is a plus h, and then we square it. So meaning here the y coordinate would be a plus h, then we square this. So now that we have our 2 points, how do we get the gradient of PQ? How do we get the gradient of PQ? You can put up your hand or just unmute and speak. But we, all of us said we know how to find the gradient of a line. So how do we find the gradient of PQ when we have the coordinates of P and Q? Kellen?
So let me give it a try.
Okay.
I think it is A plus H squared minus S squared
Minus
squared
S squared.
over A plus H minus A.
So we expand A plus H squared and that gives us a squared plus 2ah plus h squared, then minus a squared, then everything over a plus h minus a. So we can notice in the denominator that a positive a minus a would give us 0, and here a squared is positive and the other a is negative. So we shall remain with a2ah plus h squared divided by h. So on dividing through by h, the first one we shall remain with 2a and then plus h. So that would be the gradient of p of pq. Are we okay up to that point?
Yes.
Okay. Kellen, are we okay up to that point?
Yes.
So now suppose we want to find the gradient at this point P here, such that because at that point, that is where the gradient of the line is equal to the gradient of the curve. So remember, our question is to find the gradient function of y equaling x squared. So how are we going to make sure that we reduce this gradient we have obtained of the line to the gradient at point P? So we can suggest our answers. Karen, what do you think we would do? Emily, what are we going?
So first, pardon. You first repeat the explanation.
To do. Okay, the best we can do here is to reduce this area to that point, such that we reduce the h. So when this h reduces, this point here is going to move and come this way. So as h reduces, and which we mathematically say as h tends to 0, when we reduce that area, the change in x to 0, then the point q, this line or the gradient function is reduced up to point what? To point P. So we shall have that reduction. So meaning that as h tends to 0, our 2a plus h, so 2a plus h will as well tend to 2a. I hope that is clear, or you would wish me to repeat? Helen, is it clear?
Yes.
Emily?
Yes, sir, it's clear.
Okay, it is clear. So we can, so now we are going to conclude and say, so what would now be the gradient function of x squared, of y equaling to x squared?
2.
Is going to be? So remember, this was equal to x. So this would be the same as 2x. So that would be the gradient function of y equaling to x squared. So let us as well slightly go through the one of x to power 3. So let me again have my line here. So now, if my x is a at point P, so this would be a. So what would be the x coordinate, the y coordinate, if my function is y equaling to x power 3?
A plus h cubed.
Yes, come again.
A plus h into brackets cubed.
Okay, that would be for q. Thank you. Then here it would just be a to power power 3. So is equal to change in y over change in x, which would be a plus h to the power 3 minus a to the power 3. Then this will divide by a plus h minus a. So what did we get when we expand a plus h to the power 3? What did we get when we expand that? Any idea?
Then you get a cubed plus 3a squared h plus 3ah squared. Plus h cubed.
Then we subtract the a to the power 3, and then this will divide by h. So the a cubed and a cubed will cancel out. Then we remain with 3 a squared h plus 3 ah squared plus h to the power 3. Then we divide that by h. So when we divide through by h, what shall we have? On dividing through by h, what do we have?
3a squared plus 3ah plus h squared. H squared.
So that would be the gradient of h squared of PQ. Okay, so supposing we wanted to reduce that gradient to point P, what would it be equal to? You can as well give the explanation as to why you give us that answer. Just some explanation there of gradient at point P. So if we are interested in getting the gradient of the curve at that point. Okay, so what we are going to do is briefly, we said we reduce this change in x, which is h, to that, and when that is done, this line will reduce to this point. Okay. In other words, we shall have a downward. So we shall no longer have this a plus h. So it also goes away. So we finally come to point P when the h has become 0. So the h becomes 0. And mathematically, we write this as limit of 3a squared plus 3ah plus h squared as h tends to 0. So when h tends to 0, this term here will become 0. The h squared will also tend to 0. So in other words, we shall remain with 3a squared. So now that would be the gradient at point P. So finally, what is the gradient function of y equaling to x to power 3? What is the gradient function of y equaling to x to power 3? Emily? Helen, what would be the gradient function of y equaling to x to power 3?
3a.
3a. No. So when we use the x equaling to a, we obtained 3a squared. Okay. Now, if we bring in back the x, so remember our aim is to find the gradient function. So our y is x to power 3. Then when we use the x equaling to a, the gradient at point P, which is the same as gradient of the curve, gave us 3a squared. But remember the curve is y equaling to x to power 3. So when we need gradient of y, which would be the gradient function, that would be the same as 3, but here we substitute with the what? With an x. So that would be 3x to power
3x squared.
power 2. Are we okay up to that point?
Yes.
Okay, Emily?
Yes.
Okay. So let us try to look at a summary. So I've seen that if y is equal to x squared, its gradient of y is 2x. Then if y is 3x squared, so gradient of y, no, we had no 3 there. Let me remove it. So gradient of y here, if this is to power 3, this would be 3x to power 2. So are we trying to, is there any relationship we can see, or is there any conclusion we can make given these two?
Have been differentiating.
We have been differentiating. Okay, that is great. And then how are we doing the process if we are differentiating? How is the process done? Okay, maybe let us look at each one separately. So here y is the same as x squared. Then gradient of y, we are seeing 2x. Then the 2 reduces power by 1. So this is the same as 2 minus 1, which gives us 2x, because it would be to power 1, which still remains the same. Then when it is y equaling to x to power 3, here is the same as, so we first multiply 3 here. So it becomes 3, then x, 3 minus 1. So that is how we are able to get 3x to power 2. So who can give me an answer for if y is equal to x to power 4? What would be the gradient of y? The gradient function
4x.
of y? 4x
Power 3.
To power
3.
to power 3. Okay, so here is same as subtract 1, multiply here by 4. So there, if is equal to a, okay, first remove the a, is equal to x to power n, gradient of y is the same as x n, x times n, then to power n minus 1. And if it has a coefficient a, then x to power n, what would be the gradient function? What would be the gradient function?
N a x power n minus 1. To power n minus 1.
Thank you. Okay. And the differentiation. Okay. The process of finding the gradient of a function is what so I'm going to send some work to do on differentiation. So make sure you do that work because it will prepare us for our next lesson, because that work will build on what you'll be able to understand in this first topic. So when I send it as possible. So otherwise, thank you for attending this lesson. And we may end here unless if there are questions.
Should we do the back house
Do you have
assignment?
any questions?
Should
Yes.
we do the back house assignment?
Yes, please. You have the back house?
Yes.
Emily, do you have the back house?
No, I don't have.
Okay. I'm going to send it to you. Such as that we do the back house assignment. Okay. Nice day and be blessed.
You too.